Okay, so today we're going to be talking about simplifying the basic trig identities. Okay, so on this note sheet today, you're going to get all of the trig identities that you're expected to know by the end of this unit. So you do have to have these memorized. You do not get a note sheet on this. I'm also going to preface this unit with you have to try something. Okay, I am not going to help you unless you have shown me that you have tried some steps and maybe it led you to a dead end. Okay, you have to always try something here. This is not something where there's a step-by-step, this is exactly how it goes every time. We can get the same answer but get them in multiple ways. So again, you have to try something. So if you want my help, you got to bring up something where you have tried an option and that didn't work for you, and we can go back and see what option we could have tried instead. Okay, so our basic trig identities, okay, are going to just be that cosine, okay, again, is x over h or a over h, okay? Sine is y over h or o over h. Our quotient properties there is tan and cotangent. And remember, the key thing for us is with the tangent and cotangent is to really know that tangent is sine over cosine and cotangent is cosine over sine. It's another way that we could rewrite that and maybe use it as a tool. Reciprocal properties, okay? The secant is going to be 1 over cosine, just as before. Cosine is 1 over secant. We may need to know that or use it. Okay, cosecant is 1 over sine. Sine is 1 over cosecant. Cotangent is 1 over tangent. And tangent is 1 over cotangent. Okay, now these should all be familiar to you. We have talked about them in class before. So now let's look at how we might use this to simplify some sort of problem. Okay, so we have sine of 80 and cosecant of 80. Remember, cosecant is the reciprocal of sine. So if I rewrite this, I have the sine of 80 times 1 over the sine of 80. And if we rewrite those and multiply across, we will get sine of 80 over sine of 80, and realize those are the same number, so our answer there is 1. Okay, because they cancel each other out to give us 1. On the second equation, we have cotangent times secant. So let me think of ways that I can rewrite what I see there. Cotangent I could rewrite as cosine over sine. And secant I could write as 1 over cosine. My first step that I normally think of is to put everything in sine and cosine, if possible, because normally by there I can find something that's going to cancel to help me out along the way. So if I rewrite this, okay, I'm going to have cosine of x over sine of x, cosine of x. Okay, my cosines are going to cancel, and I'll have, scroll down a little bit, and I'm going to have 1 over the sine of x. Now that is not in the simplest form, so I want to keep going. Remember, 1 over sine can also be written as cosecant. So I have cosecant of x there as my final answer. Okay. And for the last one there, I have tangent of 40 minus sine of 40 over cosine of 40. My sine and cosine are already in the form of sine and cosine. Can I rewrite tangent in any way to do the same? And I can. Tangent is sine over cosine. So I have sine of 40 over cosine of 40 minus sine of 40 over cosine of 40. Now, just because I wrote it in parentheses doesn't mean it's actually different. It's just me writing in parentheses. They're the same number, so if we're subtracting the same number, our solution there would be 0. Again, that was just applying our basic identities with our reciprocal identities there. And notice how I always got it down to the one term. I got 1, cosecant, and 0. Oops. Then we have what are called our even and our odd properties, okay? Even properties apply to our cosine function, um, which in turn means that it applies to the secant as well. Negative x, I wrote that down. So secant of negative x equals secant of x, okay? The even properties apply to our functions that have y symmetry, so they're symmetrical across the y-axis. So if it's a negative on the inside of the parentheses, it'll be positive on the outside. So again, this applies to our cosine and our secant function, since it is the reciprocal of that. Okay, the odd properties apply to those functions that have symmetry about the origin. And so this is going to apply to sine and tangent and their reciprocal functions as well. So it'll also apply to cosecant and cotangent as well. So here what happens is if there's a negative on the inside, we pull the negative to the outside. So it's a negative sign. So for even properties, a negative on the inside just makes it positive. Okay. For odd properties, it makes it a negative on the outside. So let's see how that works. So we have cosine here, and realize that cosine was indeed an even. So this is actually equal to the cosine of 30. Okay, and cosine of 30, that's our pi over 6 family. So our cosine there would be the square root of 3 over 2. And that would be our final answer there. Okay, the sine of negative 60, the negative pulls out this time. Okay, so we'll have negative sine of 60, and realize that 60 is our pi over 3 family. So that will be negative square root of 3 over 2. Okay, and the last one, we have cosecant, which again is the reciprocal to sine. Okay, and sine is a odd function, so it's going to pull out in front. So we're going to have negative cosecant of 45. Okay, and if you can't remember what the cosecant of 45 is, remember it could be the reciprocal of sine. So sine at 45 is the square root of 2 over 2, and I need to flip it. So if I flip the top and the bottom, I would get 2 over the square root of 2, and I can't keep it on the bottom, so I multiply the top and the bottom by the square root of 2. And I would get 2 square root of 2 over 2, where the 2's cancel. So my answer here will be negative square root of 2. Okay. Again, those were our even and our odd properties. Just to recall, even is cosine and secant. Odd is sine, tangent, cosecant, and cotangent. So then we have what are called the co-function properties. These are probably one of the harder ones for kids to remember. But anytime you see pi over 2 or 90, okay, it could also say 90 degrees because pi over 2 is represented by 90 degrees. They want you to use a co-function property. And what the co-function property says is that sine, okay, of pi over 2 minus x is equal to our cosine function, okay, where cosine pi minus 2, or pi over 2 minus x will be the sine function, okay. Tangent pi over 2 minus x will equal cotangent, cosecant of pi over 2 minus x will equal secant, and vice versa. For secant will equal cosecant, and the cotangent there will equal the tangent. So let's look at how we might use that. So cosine pi minus 2 is going to give us sine. Okay, and sine of pi over 2 minus x gives us cosine. And sine over cosine is equal to tangent. So our final answer there would have been tangent of x. On the second one, cosine of pi over 2 minus x gives us that sine of x times our cosecant. Okay, I'm going to write these in two separate steps. I don't want to confuse you. So we changed the first one. Now again, I want to put everything in terms of sine and cosine, so I can rewrite cosecant as sine as 1 over the sine of x. Okay, and then if you multiply that out, that's sine of x over sine of x. Okay, and that gives us a value of 1. Okay, now this bottom one is a little trickier. Okay, so if we look at this problem, we can rewrite what we have there. So cosine of 10 degrees could also equal sine of 90 minus 80. I apologize. I mean the sine of 90 minus the angle we have there, which is 10. Okay, over sine of 80. And if we simplify 90 minus 10, we do get the sine of 80 over the sine of 80. And that gives us a value of 1. Again, for that top part, cosine, okay, cosine and sine are related by pi over 2 minus x. So our x here is the 10. Okay, so if I wanted to switch to sine, it would have been 90 minus my x value, which was 10, which is how I got the sine of 80, because 90 minus 10 gave me 80. And they would simplify there. Again, these were the co-function properties. So the last ones on your note sheet are known as the Pythagorean identities. Now, these are the ones that kids struggle with noticing a lot, and you use these a lot. So I would strongly suggest making sure you understood the Pythagorean theorem identities here. So the first one says that sine squared plus cosine squared equals what? Which if you look to the right here, that makes sense because we have one leg squared plus the other leg squared equals c squared, right? We're still using that Pythagorean theorem. Okay, but we're using sine and cosine in there as well. Now, we might use it in this form, that sine squared plus cosine squared equals 1. You also may see it as 1 minus sine squared of theta equals cosine squared of theta. Okay, you could also see it 1 minus cosine squared of theta equals sine squared of theta. Okay, so we might have to use that one property in one of those three ways in order to substitute another piece in. Okay, from that we also get that tangent squared plus 1 equals secant squared. Okay, now I could derive this for you if you wanted, so please ask me in class if you want to see the how it is derived. But last year I found that it confused a lot of my kids. So if you want to see it, I will gladly show it to you, but please ask me in class. Okay, so another way we might see this written is secant squared of theta minus 1 equals tan squared of theta. That might be another way we would use that one. Okay, and then possibly you could use it as secant squared theta minus tan squared of theta equals 1. But mostly you'll see one of the top two as being helpful to you. And the last one there is 1 plus cotangent squared of theta equals cosecant of theta. Again, we could also see it as cosecant of theta squared equals minus 1, sorry. Minus 1 equals cotangent squared of theta. And these are going to be the top two ways that you'll see them written. The last possible way you could see it written is that cosecant squared of theta minus cotangent squared theta equals 1. But again, these top two ones are going to be the ones you use most when talking about one of those two functions. The top one, you'll use all three. All of them will be extremely helpful to you to know. Okay, and again, I got those pieces by just subtracting pieces. So on the top one, 1 minus sine squared of theta, I got by subtracting sine theta to the other side of the equation to get cosine squared by itself. And that's how I got all of those pieces there. So if you just know the original and you can derive to those other pieces, it's extremely helpful to you. Okay, so let's look at some examples. So we have 1 over 1 plus cotangent squared. Okay, so cotangent squared could also be written as cosecant. So this is 1 over cosecant squared of theta. Okay, and then again, we don't want to leave anything as a fraction. So then that actually equals sine squared of theta if we take the reciprocal of it. And that would be our final answer on that one. Okay, over here on the second one, again, I like things to be in terms of sine and cosine. So I noticed that my first one there is in terms of sine. So I'm going to leave that one, sine squared of 20 theta plus. Then I have 1 over secant squared plus 20. So I could either use the reciprocal function, which would give me cosine squared theta of 20, or I could try to use my Pythagorean identity, saying that secant was 1 over tangent. That second route, just looking at it, I can tell is going to be a little more messy, but you could still get the same answer. The easiest way would be to take the reciprocal. So if I took the reciprocal, I would get cosine squared of theta, of 20, sorry, it's not theta this time, it is 20. So 20. And sine squared plus cosine squared is one of those Pythagorean identities. So here our answer would be 1, because sine squared plus cosine squared equals 1. Okay, down on the bottom, we have cosecant squared of 42 equal or minus 1. So if I replace cosecant with its Pythagorean identity, it's going to be 1 plus cotangent, that should be a t, 1 plus cotangent of 42, don't forget to square it, minus 1. I have a positive 1 and a negative 1, so those cancel, and we're left with cotangent squared of 42. Okay, and that would be our final answer. Now, I do normally say I want it in terms of sine and cosine, but remember, if I put cotangent in terms of sine and cosine, it will be a fraction, and I don't want my answer to be a fraction. I want it to be a single term, like cotangent squared of 42, which is not on the unit circle, so we don't actually have to find the value there. Okay, so the next couple on your test or on your note sheet is practice, and I'm going to do a few of them with you, and I'm going to leave a few of them blank that I would like you to please try on your own. So the first 3 there are exact values, which means we should get a number of some sorts. So if we take secant squared of 58 minus tan squared of 58, I'm thinking I see the squares, okay? And as soon as I see squares, I'm thinking it's probably some sort of Pythagorean identity. So if I think about a Pythagorean identity that works, secant squared is equal to 1 plus tan squared of 58 minus tan squared of 58. So the tan squareds there will cancel each other out and make a 0, and I'll be left with the answer of 1. So I would like you to please try the next two there on your own and see how it goes, and we'll talk about them in class. So go ahead and pause the video and work through them. Okay, on the next 6 problems there, I'm going to do the first 3, and then I'm going to ask that you do the last 3 there on your own. So tan x of cosecant of x. So I can rewrite tan, if I'm thinking in terms of sine and cosine, I can rewrite tan as sine of x over cosine of x. And I can rewrite cosecant as 1 over sine of x. Okay, and I have a sine of x on the top and a sine of x on the bottom. So those will cancel each other out, and I'll be left with 1 over cosine of x, which I can rewrite as secant of x as its reciprocal function. So that would be the answer there to the first one. Okay, then we have 1 minus cosine squared. As soon as I see that squared, again, I'm thinking of my Pythagorean identities. Okay, and so 1 minus cosine squared is going to give me sine squared, okay, of theta. And then cosecant I can rewrite as 1 over sine of theta. So I have 2 to the power, sine is to the second power there on the top, and it's to the first power on the bottom. So when we have the same thing with different powers, we subtract our powers, and we'll be left with just sine of theta in the top. It'll be sine of theta over 1. Okay, and the last one I'm going to do with you is the cosine of negative x times the cosecant. Now remember, cosine is an even, so that means the negative version and the positive are the same, so that's just cosine of x. Okay, and then we have cosecant, which is 1 over sine of x. So we have cosine of x over sine of x, and cosine over sine is cotangent of x. And that would be our final answer there. Okay, so please try the next 3 there on your own. Remember, if you see something squared, I would try one of my Pythagorean identities. In class, we will be doing lots and lots of practice on this. So please come with questions, and I'll be ready to answer.